Hello to everybody. My name is Damir. I'm from a firm called Cross, and today we're going to talk more about MLOps principle, and we're going to try to talk more about use cases also where, like streaming use cases where MLOps and integrated it with the MLOps. So before I start with the content, I just shortly on one slide wanted to introduce myself and company where I'm working. So we are coming from Cross, which is based in Zagreb, Croatia. We have multiple offices throughout Croatia, but we also have offices in Munich and some of the representative offices in the States and Amsterdam as well. We're proud to do and craft meaningful solution, and really what we try to do always is to make best out of technology and craft custom solutions for big clients like telcos, banks, and governments. We have more than 300 team members, mostly engineers, that are covering full product development, and we work on more than 1,000 projects worldwide. What we specialize in is cloud native development and DevOps. We also love to do everything with data, so like the lakes, the data warehouses, maintaining it, building it, data strategy. This is what we really enjoy to do. So we also have daughter company Cross AI, where I work, and it's mostly focused on implementing machine learning in various ways. And obviously, as we are working with big clients, integrations as well, big part of it. So that's about it. If you have more, if you're interested about more info or anything, feel free to ping me. And now I will just start with the main content of this webinar. So before I start with some of the solutions, I wanted to start about why would we even care about machine learning, and what is new here with streaming data, just to give a glimpse of why are we doing it and what are some of the problems with the current state. So obviously, I mean, there are several cases where machine learning can definitely help and improve on problems that aren't even connected to the streaming world. For example, we had fraud, we had predictive maintenance, we have the recommendations even before the streaming. But adding this extra layer of getting the data in the real time with the streams, we definitely can add additional value or react in the real time, and definitely allow some of the use cases that were not possible before. So, for example, on the fraud detection, we were, for example, working on a project where definitely we were getting a lot of card transactions through the stream. The key objective was to detect the fraudulent transaction, but it was equally important not to block, obviously, the transactions that shouldn't be blocked, like non-fraudulent transactions. And even though here you can build some rule engines that can help you detect fraud, implementing machine learning solutions can definitely boost up the results and detect much better than with the rules. And obviously, in all those cases, I mean, adapting to for example, in fraud is adapting to new behavior, and really this real-time component, sometimes it's crucial, because on one hand, we need to react super fast. So what I mean here is, for example, we need to react within 300 milliseconds maybe, or I mean, this information would not help us solve the problem, because either we block it within the 300 milliseconds, or I mean, we don't do anything with that transaction, we just let it through. So this real-time aspect is crucial, but also really combining the long-term behavior data and also the short-term. So how maybe the user or merchant is behaving within the last 5 minutes or minute can really help us to get this additional value that we were looking for. The second case, I mean, from the technical side, it can also be similar solutions. So we are looking for something where, for example, we were working with a telco where you have a lot of operational logs from the infrastructure and from the network, and you want to detect contextual anomalies within such system. So in order to detect this, I mean, you need to, in the real time, ingest large amounts of data that are coming from various sources, and then make machine learning model that would kind of detect whether we have anomaly or not. And if we are catching anomaly, it would be also good to kind of describe whether the anomaly, where is it coming from, what is the root cause. And obviously the systems can adapt over time, and they always adapt. So adapting our models so that they are kind of tracking the new states that where the machine, application, or user can be, it's pretty important to have that as well. For the recommendation system, it's similar story. So it is basically a system that can work without streaming. So we can have in the background, or we can kind of calculate in batch way, like prepare the recommended products. But we can also really combine this with large amounts of click logs, user behavior while the user is on the page, and then even serve more personalized offer based on this short-term but also long-term behavior that client might have. So these are all the problems and use cases where streaming and machine learning can work. But before talking about MLOps, I wanted to also talk about what does it take to build a model that would solve problems like this. And obviously, when we are thinking about this process, we can define few bigger steps or activities that will that will have as an end result like the model. But we also can have a few pain points with each and every activity. So for the first activity, I mean, we first need to gather and collect all raw data that we will use to train the models. And usually when we are kind of collecting that data, for example, for the fraud, for the recommendation systems, you're getting that data from multiple sources. And sometimes this process is not so easy, because we are talking about a lot of data, we're talking about a lot of sources, and often we need to kind of check whether the data is clean, we need to clean the data, and this process takes time. So usually we want this process to create once, and then if we're retraining the model, or if we are training similar models, we don't want to, again, spend a lot of time. So we want to automate this kind of step in order to save time in the future. The next activity is usually creating the features. So based on the raw data, for example, in the fraud case, we want to create short-term and long-term aggregations. In the predictive maintenance, probably we want to kind of collect logs within some time period, maybe 30 seconds or minute or something like 5 minutes, and then create features based on those aggregations. And usually, I mean, we would like to reuse some of those features within different projects, within different model versions. And as well, having the tracking and having the registry of features can help us, again, speed up, iterate more faster. And we definitely would like to kind of solve this pain. Also, I mean, sometimes calculating feature can be easy, but if we are talking about really crunching a lot of data, and if we are crunching a lot of, and if we're having aggregates that are complex to calculate, for example, if we are talking about crunching long-term aggregations for example, like 9 months user behavior and things like that, usually it involves a lot of engineering to kind of calculate it. And we want to kind of lower these barriers so first that more people can do this. And once, maybe if it's hard to calculate, that once we calculate it, then it's easy to reuse, and that we can reuse this feature for multiple different models and teams. The third part is once we have features that are kind of prepared, we are building our first data set that would be consisting of those features. And to train the model, we usually use either GPUs or some specialized environments, which can help us to train the models, for example, faster. But they can also be sometimes tricky because, for example, if we're using GPUs, we usually need to set up the CUDA drivers, we need to install all the dependencies, and sometimes those dependencies can be tricky because one version of one package may not work with combination of other two packages if they are not, within the right versions. And all these tracking of environments can sometimes, for data science engineers, can really be like a pain, and we would like to have a solution for this part. As well, it can happen, for example, that if I have everything, all the packets that I need, and it's working, I can train the model, but some other data scientist maybe would have some other versions, so maybe older or newer version of the packages. Even though we can both train the models, we may not have the exact same results, which can then be hard to debug. Why is this model working better or worse if we are not tracking of what's within our environment where we are training the model? And as well, when we are training the models, usually it's not that we kind of just train the first model and that's it. Usually the first model, it's maybe not the best one. So we want to test a lot of different things. So for example, we would like to change the hyperparameters and maybe do a grid search to find the best combination. Maybe we would like to test multiple different model architectures. Maybe we would like to try different combinations of the features and stuff like that. So all of these experiments, even though it is helping us to find the best result, we can sometimes, kind of lose track of what we tried, what we didn't try, and it would be a good solution to have some tracking mechanisms so we know what we tried and what we still didn't try. And the last one is, once we have model, we need to evaluate it. So we need to say whether this model is kind of performing well. So what I mean by this, I mean that whether the metrics are good. So for example, if the recall is good, if the F1 is good, is the model robust? Also, we would like to see on what examples the model it's working, but also on what examples the model is not working. And usually what happens here is that project by project, engineer by engineer, maybe these evaluation techniques are not the same. And we would still like to standardize this in a way so that we really can compare apples to apples each time, so we can really decide whether the model A is better than model B, so we can kind of promote it to production if we really do believe that model is kind of better than the previous one. Okay, and all of these activities and pains can help us kind of get to train the first model. But in order to really get this extra value that I was talking at the beginning, we really need to use that trained model. And now I would like to do the same thing for this second part of the machine learning. So really using the model and what does it take and what are the usual pains. So first, if we are talking about the streamings, we would have a stream. So we will have a stream of raw data. And the first question would come up is, do we have everything? So usually it can happen that maybe when we are training the model and we are having the data set that is stored somewhere in the offline store, we may have everything what we need. But when we are connected to the stream, it may end up that we don't have everything that was available to us in the offline store. And this is something that we don't want to kind of have problems like this, because then, I mean, what we trained, we cannot kind of do the same thing and retrieve the features in the inferencing phase. The second thing is like the schemas, whether the data types are the right, the formats, but also, how we are kind of, if we are rounding the numbers, decimals and stuff like that, those small errors can make big kind of problems when we are doing the inferencing of the models. The third part as well with the streams is when we are working with the offline data and training the model, we have like the static data. So whatever we have for us, for the model when it's training, it's correct. But what can happen is with the read raw stream, what can happen is that we have a delay, and maybe we don't have the correct data for that timestamp. So we would kind of not do inference on the same data as we were doing on the offline data that we used for the training. The second step is, again, calculating the features. It would be super important to have exactly the same features, because then it would allow us to get really the same results. So something what can happen is that maybe not the same code base is used for the training and for the inferencing. And this can also be a tricky situation, because then if we have two developers, one doing the inferencing, one doing the training, and we create a bug within this pre-processing phase, for example, or creating the features, then we can get completely different results on the inferencing phase. As well, as it was maybe easy to prepare the features in the offline world for the training of the model, for some use cases, calculating features fast enough is super important. As I said, in the real-time scenarios, even though we can calculate the feature, for example, and we have hours to calculate all the features, or days even, for our use cases in the real-time world, we need to calculate these features like within 100 milliseconds or even lower. And if we cannot do this, then it's a problem for us, because the transaction, for example, will pass and we will not be able to block it if it's fraudulent. Or there's also case of, can we scale the whole process of calculating the features? Because what happens if maybe we have peaks, maybe a large number of logs would come, and then we would have bottlenecks, and we would have backfills that would not allow us to process all the logs that are coming in the real time. The next step is using the model. This is the most interesting part, because we are coming to the time where we are really using the model. And there's this question of how should we deploy that model? So whether this will be like a standalone service, whether this will be integrated with the streaming processor, those are all the questions that we need to decide. Sometimes it's a trade-off of kind of architectural complexity. Sometimes we need to kind of more tweak it to the latency side, but it can be sometimes super tricky. Also, I mean, similar to the calculating the features, are we kind of calculating it fast enough? And the last thing is also, can we easily update the model? Because as we said, we want to adapt to new situations. We want to kind of maybe every week, every day, plug in a new model. So how easy it's to update model in streaming? So do we need to kind of restart the whole thing, or we can just update the model? So those things can sometimes be pain, but also there are some cases where we want to continually kind of with every example maybe learn the model, and we need to kind of see how to implement stuff like this. And the last thing is monitoring. So if we don't monitor it, same as from the standard engineering world. So if we don't monitor it, we won't see it. So the question comes, okay, but what should we monitor? Should we monitor on model, the whole infrastructure, every single part? How will we kind of, if it's a distributor system, how will we kind of sync all the clocks? What if on what data will we evaluate the model? So, for example, if we want to kind of say whether the model is still good enough and it's in production, what data will we use to kind of say whether the model is working? And also, in the end, do we know whether the whole service is working by the SLAs, or do we have any hiccups or stuff like that? So those are all of the activities, but I think I outlined a lot of questions and problems that we need to solve in order to integrate machine learning that will kind of help us and bring some extra value. Before I go to solutions, I just wanted to briefly describe that usually when we come to point that we train the first model, it's not that we finished our job. So usually what comes up is that, okay, we did it on the dev, we need to kind of make production environment. We deployed the first model and we make first predictions, and we're kind of super happy because this is what we wanted. We wanted to kind of train the model and build it, put it to production, and that's it. But usually this is not the last step. It is just the beginning of a project. And this is, where even more stuff where MLOps can help comes to play. So here, the next step is usually, okay, model is deployed, but over the time we may see that we have certain problems. So what happens maybe is that, okay, we have a Flink application that's kind of helping us, but after a week or two, we have problems with, I don't know, checkpointing or RAM, or latencies are, going up, or maybe our model, because we implemented that, we are kind of getting the feedback mechanism, and we are seeing that maybe our model is not performing well enough. There's also a question of maybe somebody asks, okay, but how did we come up to this model? On what data was it trained? Do we know that? What pre-processing was used in order to help us detect and troubleshoot where the problem is? If we don't have full lineage, we may not do we cannot answer the question. And also the last thing, it's not the last thing, but last thing on the slide is how it is super important to kind of track how long does it take to kind of train the new model, but also deploy the new version. So is it days? Is it months? Is it quarters? So it's really important to kind of track it and try to lower it. And we will talk more about how to help with this problem. So as I said, during this first part, I just wanted to outline why are we doing this and what are the key pains of deploying and kind of solving the machine learning plus streaming. And now I'm going to talk more about MLOps and how can it help. So as the word says, so machine learning operations. So it's pretty similar to the DevOps world. So all the best practices from the dev world, we're trying to apply to the ML world. And I think, as you saw from the beginning of this presentation, in order to have such system, it takes a lot of different functions, a lot of different teams, a lot of even different people, and we kind of need to make some ways how those people can collaborate in order to solve those problems. And first big pillar is definitely automation. So as I said, we want to kind of lower time that it takes to deploy the model, train new model, test new feature, experiment with different things. And we will see how we can kind of automate and lower all those metrics. The second thing is definitely monitoring. So how can we monitor and what should we monitor? But also adding this governance perspective of really understanding and having full traceability of the process. And the third thing is, as obviously we will have a lot of infrastructure that needs to kind of support our models. We will also have some new stuff that is specific to the ML. So we will talk maybe about feature stores. We will talk about model registries. We may talk about infrastructure that's maybe a bit different because we're having GPUs and stuff like that. So we also need to see kind of how to connect all those dots in order to help us solve all those questions that we have. So let's start. So one of the first things how automation can help is it's similar to the kind of classical development, but just applied to the machine learning world. So, and I'm just going to here show one simple example of how we can automate and maybe make a more reliable solution in one short demo. So as I said, the first step is training the model, but usually after some time we would need to kind of train the new version of the model. So let's see how we can do this. So obviously we will have data scientists that will play around with different models, and over the course of maybe a few days, he would try many different models that he would save to the experiment tracker. But at one point, he would find a solution that he wants to kind of, that the model is good enough and that we can try to deploy to the production. So what he can do is he can train the model. He for the training of the model, he would use the code base he's writing or using, and he would also have this training configuration that would kind of help him define all the parameters, hyperparameters for the models. So what he can do is he can register the model and all the experiments he did to the model registry. So as we do for the code, we would just put this to the registry. But what we can do is we can also push to the Git the configuration, but also if any code was kind of changed for the pre-processing, post-processing, training, and stuff like that. And this will be like a new branch on our Git repository. Once this is kind of done, what we can do is we can create a CI/CD pipeline or part of the automation that will help us first with the testing. So what we are first here testing is we can do a lot of stuff. I'll talk a bit later on testing, but here we can test, classical things like unit tests, but we can also put some machine learning tests so that we make sure that model is working and the code that should be kind of that is responsible for the model, that it's working properly, and this is done fully automatically. So this is the first step. Step after that is if everything's green, if everything passes. Now the first experiment, we can put that experiment to the staging environment that's registered to the model registry. And once it's ready, it will be like registered as a new version, but in staging environment. And we can go to the next step in the pipeline. Then what we can do, so we did some automatic testing. We can also do some, for example, if it's highly regulated or super important, high stakes, so for example, fraud, we can also do some manual testing to the model, do some analysis. But we can also automatically compare the new version of the model with the previous version or the version that's in production on some golden data set, and only if it's better on all of the metrics. And this cannot be only recall, this can, or F1, this can as well be, for example, like if the model is kind of robust enough, if we have some hour rules and stuff like that, everything that can be put, it can be put as a golden data set or golden rules, and then it will be automatically tested. And then if this all the tests, manual and this automatic pass, what we can start is we can start the deployment script. And deployment script would usually mean that we are kind of promoting this staging to the production, and we are kind of calling the ML service, which would then kind of take the new production version to the model registry, and within the next cycle use this new model and do the predictions on the new model. Okay, so this was really the first thing that can definitely help us automate some of the stuff. But let's also see what we can test. So I said that there are some classical things that we can test, like really test the code and do the classic unit tests, integration tests. But we can also test stuff that's specific to the model. So we can kind of load the trained model and do one simple prediction just to see whether there's any kind of error in pre-processing, post-processing. We can also check whether everything's here what we wanted. So maybe we want to have the predictions like is it anomaly or not? Should we block the transaction or not? But we also maybe want to have a confidence. So do we have a confidence and whether it's the interval is correct? Maybe we want to have as well the feature importance. So do we have that? Is the format again in the proper way? So all the things that we can kind of put and define in the test, it would be kind of good to have it here. And then with each and every version, we can automatically test for this. As well, as I said, the same thing goes to the evaluation test. So we can kind of define the standard evaluation metrics and then use the golden data set to kind of evaluate whether the new model is better than the previous one. It's just important then that in streaming world, in some cases, we need to adapt this golden data set because, for example, something that's changing super fast, if we're kind of comparing with the static golden data set that is old, it will maybe send us the wrong, it will send us in wrong direction. So we need to kind of have a process for curation of this golden data set all the time. And definitely the third thing is that sometimes we as well want to test the infrastructure for the training. So maybe just training on one batch, just to see, whether the inputs are scaled, whether the data is again in the input data is in the right format and stuff like that. These are as well things that we want to kind of test here. But those are all the things that we can kind of do with every single thing fully automatically, with every single version of the model. But there are still some tests that we want to do, even though we did all these things. So what we can do is we can, for example, in a fraud case, even though we did the testing, the functionality testing, the evaluation testings, the infrastructure is working as well. What we can do is we can deploy a new version and connect it to the production data, but just running this model in the background, and then validate the new fraud model that it's really working well. So what we can test is here really, because maybe we're using the more complex model, whether the latencies are still good enough, how the model is really behaving on the data in the real time on the production data, and whether everything's working. And then only maybe after a week or two, once we are completely sure that it's good, then promote it and set it as a new production model. Or in some cases, for example, if we are talking about recommendation systems, so we don't know what would happen if we did the other thing, or if we recommended the other product. So what we can do is we can load the trained model and then do prediction on certain parts of users for this new model, and then see what are the results of this model, and then once this model is good, then deploy to the old users. So these are the things that can help us make more reliable system over the time. Okay, so we talked about automation. We talked about the testing, but what about deployment of the system? So usually, if we are talking about the streaming, we are receiving the data, for example, from some kind of topics. So we would have data on one raw data topic, and usually we would collect this data, make a streaming processor that would create features. Then we would maybe publish those features to the enriched data topic, and then we would again consume those features for our model. And this model will then again, once it calculates the score, but also other stuff like confidence, feature importance, stuff like that, and like version ID of the model, we can publish this to our inference topic that can be consumed for other things. We may ask, but where this inferencing service will get the model from? So usually, as I said, we want to have a model registry, which is a service that will host all our models, but it will also have all the metadata about our models. And what we will have is we will have our production model that we're going to use to inference every single data point. But if we have every single topic from every single this part of the process, we can also store all these things. So we can store the raw data that comes, or we can store also the prepared features, but we can also store the model inferences. This will later help us really to make sure that we have a constant feedback loop. But for now, by implementing feature store like this, what we can do is when we are creating the features in the real time, we can store them to the feature store, so it's ready for model retraining later. So, and by doing this, basically we are calculating the features in the real time, and then we are not calculating again them in the offline. So we are sure that features are completely the same when we will do the training and when we will do the inferencing. So this is as well one good thing. But as I said, if we are having this robust ML inference service, what we can do is we can also in the parallel have multiple models that we would run. So it can be multiple production models for different use cases, but it can also be models that are just in shadow testing, and again plugging in all these inferences to some data store that will help us to kind of monitor how they're performing and to validate all the results. Okay, I talked as well about implementing the feedback loop. So obviously this is super important because it will allow us to continuously improve the models. And for example, in all of those use cases that I mentioned, we can implement it. So as I said, we will have topics where we are getting the raw data, the features, but also the inferences. But what we can do as well is once we are kind of labeling, once we kind of calculate the result of the model. So for example, in the fraud case, this will be, should we block it or not? Sometimes, or usually, if the transaction is kind of fraud, usually after some time, analysts in bank would kind of go through this data and really check whether this was false positive or true positive. So we would get the info about user action or label this transaction. And we can also save this to our data store, which will allow us firstly to kind of do the model monitoring. So first, we will know from the timestamps of each and every part of this system to kind of what are the latencies from the raw to the calculating the feature, from the feature to the inference. But we would also get info about the data drift. So maybe, the data is changing over time. We can compare it to the training data that we have. But we can also see, what our model said and what was the correct label at the end. And we can track this over time and then see maybe that our model is degrading over time. And once we see that we have a problem or that we have a large amount of data that's kind of ready to train the new model, we can periodically do the model retraining. And we can do this completely automatically in some cases or semi-automatically. And this is one of the first steps as well where MLOps can help, because we can automate and then lower time to prepare this new version of the model. And then the next part is, as well, as I said, having all these features ready, it can help us to do some model experimenting, because then data scientists can use this data store kind of to try new models, try new architectures, and see whether we can improve the model over time. And obviously, once we have a new version of the model that's done by retraining, or if we tested and made new model by experimenting, we can redo the whole process of GitOps, and then it will end up in our model registry. It can be later deployed to production. And at the end, last but not, but also equally important, is monitoring and governance. And as I said, monitoring is one of the key things, because if you don't have it, you really don't know what's happening. And governance as well, it's equally important, because it helps you really debug problems when they arise. So it is all about kind of reproducing the results of the whole process. So when we are doing the experiments, we really want to kind of know on what data set was this trained. So either this will be like the time period that we used, or this will be like set of features that we used, or this will be also the code that was used to create that data set. So what pre-processing methods and stuff like that. And one easy way how to do this is to store, for example, code hash of a commit or something like that, to store hyperparameters of the model that was used, to store evaluation scores that we got, but also to store the environment that was used in order to train that model. And once we have the experiment that is good enough, what we can do is we can kind of promote this or register this as a model, and every single registered model should have like job or experiment ID that was kind of used. As I said, we can automate part of testing and deployment of that model, and we will also probably have artifact that's kind of describing the model weights or the model architecture that we're kind of using. For the modeling, for the model monitoring, we definitely want to kind of, based on use case what we have, for example, if we are kind of detecting anomalies, we definitely want to kind of check whether our data is completely different when we were training, and we can kind of calculate the divergence of those two things. Or we can also track it versus some reference window, so we can kind of compare current data with the data maybe a week ago, month ago, and stuff like that. We can as well try to put or try to define rules. So for example, if we are having system, for example, fraud or a recommendation system, and if we are having a variable named age, and if we are getting number 200, probably it's an incorrect or we have an error. So putting rules like this and automatically checking, compliance of these rules can help us detect problems with our system before we have, a major outages of the system or problems. And also the last thing is trying to implement this feedback loop by, so which will allow us to continuously relabel the data, new data that's coming, so we can kind of really implement model performance and say whether our model is degrading over time and whether we should kind of retrain the model. For different use cases, infrastructure monitoring, it's more or less important, but I would say it's always important because having, if we're having stream processors that are maybe in big states and stuff like that, over the time, for example, we can have problems if we are kind of using a lot of RAM or our disks may kind of get full and stuff like that. So we may have hiccups with our infrastructure, and we want to detect it on time. We also want to track, our latencies. If we're talking about real-time scenarios, is it, as the load goes up, what's happening with the system, and then detecting all those situations and make kind of alerting mechanisms that will allow us to kind of, again, retrain the model or rescale infrastructure or change something within the system. So this is kind of an end of the prepared content. So at the beginning, I just wanted to outline the problems and the use cases. And I hope that throughout this time, I gave some of the solutions and answers of those questions. But if you have any questions, feel free to ask me now, or I have QR code of my LinkedIn or webpage of Cross, so feel free to reach and ask. So that's it, and I'm here if there's any questions. Thanks.